Why do we care? Let's look at some examples. Here we have an object that moves on a straight line, and its velocity function has this graph. Then the area between the graph and the t-axis, the time axis, is the displacement. So we know that the distance traveled is time times velocity, right? Because velocity is distance divided by time. So on every tiny interval of time, the object is moving by this area, this tiny area. So by the time t equals b, the object has been displaced by this area, the blue area, from its original position, wherever it was. Assume there is some line somewhere, and the object is moving on that line. And then if we integrate in this situation from time 0 to time b of the velocity function, you get the displacement of the object during that time period. Here's another example. In this example, x represents units of certain product being produced. C prime is the derivative of the cost function, which is also called marginal cost. To understand what it means, C prime of x is the cost of producing the xth unit, approximately. And if we add all of these costs, for example, for this unit, there will be this much cost, right? If you add that cost to another unit cost from all the way from A to B, then you get that area between the graph and the x-axis, which we represent by integral from A to B of C prime of x dx. And this gives us the total cost of producing B minus A units beyond the first A units. So it's the net change in the cost when we raise the production level from A to B. And of course, it's the cost of producing B units minus the cost of producing A units. And that's the net change in the cost. So here's our last example. The function f of x is a density function. It could be a probability density or a density function from physics. Mainly think of distributing mass over the interval A to B, and in some parts we are distributing more mass, like here the height tells you the mass is that high. So for every little piece of that interval, when you multiply that length, that tiny length, by the density, what you get is mass. Because we know mass is equal to density times the length in this case. It's a linear density. So by adding all these little areas, you get the total mass from A to B, and we represent it by integral from A to B of f of x dx, and that's the total mass distributed over the interval A to B. And this ends the video.